So for today, we'll just be talking about really basic object-oriented programming concepts in Python. And don't like worry about the terms and stuff. This is mostly just about how do you make classes in Python and how do you like we'll talk about like data fields and um different like methods and stuff you can do with like classes in Python. All right, so our agenda today is just like talking about what is object-oriented programming, what are classes, and then more specifically for Python, like how do you make class data fields, how do you make class methods, and if we have time, but probably not, for four basic principles of object-oriented programming. All right, so first off, what is like OOP, which is object-oriented programming? It's basically a programming design concept, as you can put it, like a programming paradigm, basically, where code is based off of things called objects. So objects can be things like cars or like animals, like just like your basic objects in an abstract sense. And these objects will hold things like data and code, which will form fields, which are basically your class variables, and functions, which are class methods. Any questions about that first? So basically, like in this example, you can see we have a class called car, and it can have methods like get fuel or like set speed or drive. And then it can also have attributes or fields like fuel, max speed, number of wheels, color, stuff like that. All right, so first, just a basic overview about classes and data fields. So first off, an object is a collection of variables and functions that like describe something abstract. So for example, a car can be an object, animal can be an object, basically a very abstract thing you want to define using variables and functions. A class is basically a blueprint of an object. So in the previous slide, we had like a class called car, and that is basically like a blueprint that you can like make an object of a car. Basically, it'll tell you like what attributes a car should have, what a car should be able to do, and what information a car can store, basically. Another thing is an instance, which is like the object itself. So when you create an object, it's called instantiation. So that is just like based on a specific class. Next, like more specifically for Python, the self keyword refers to the instance. So if you use the self keyword in Python, you're referring to the instance, like the instance of that class. Next, an attribute is just any property of a class. So it can be a variable or a function. And finally, a subclass is a class that inherits attributes from another class. All right, so first off, we'll talk about class data fields. All right, so a data field is, if you remember, is something like information that a class can store. So like, let's go back to our class car example. If we have a class called car, a data field that we can have in car could be something like number of wheels or max driving speed or the color of the car. So these are information that a class can store. A data field has two types. One is static, which is data that is shared across the entire class, or one that is instance, which is data that is shared or that is kept only by the instance of that class. So going back to the car example, like we can have a static data field called like total number of cars. And that would be, the total number of cars would be the same across any instance of a car. But like something like the color of the car or the license plate number would be different between each instance of a car. And that would be an example of an instance data field. You can also control the visibility of your the data in your class. So there are three types. One is public, which is a field that everyone can see. One is private, which is a field that can be seen and changed only within the instance, or like only within the current class. So for example, a public data field can be the color of a car because everyone can see that. And sorry, just a moment. So basically, a public data field could be something like number of people in a car. That is a field that can be seen and changed by anyone, but a private data field would probably be like we could say like the type of engine the car has, and can be a field that can be changed only within the current class. Finally, you also have something called protected, and that's a field that can be seen and changed within the current class and any subclasses of that class. Any questions about like data fields so far? All right. Finally, we'll talk a little bit about class methods, and then I'll walk you through some demos that will make all of this a little clearer. So class methods are just something that allows objects to perform actions. So like if you have the class car, you can have methods called like drive or speed up and slow down. And those methods would allow the car to actually do things instead of just holding on to information. Similar to data fields, you also have static and instance methods. So like a data field, static is just the method is tied to the class and not the instance. And instance's method is tied to the instance of that class instead of the class itself. So the syntax is just, if you want to call a static method, it's the class name dot method. And then if you want to make a static method, you have to use this static method tag. For instance, when calling it, it's just instance dot method. And then making a instance method, it's just like making a regular method within the class, but you have to pass in self as the first parameter of that method. And overall, a class has three important functions. So first one is constructor, which just makes an instance. Second is setters, which will help you set variables in the class. And finally, you have getters, which helps you access variables within class. Technically, all of these are optional methods. So technically, like you don't have to have a constructor, but you'll never be able to make the instance of that class if you don't have a constructor. So first are constructors. For Python, constructors are defined by the double underscore init double underscore method. If you don't define init, you won't be able to create an instance of the class. And first off, we can look at a demo of this. So in this instance, you have a class called dog, and you have like a static variable called dog count. So we could use this to actually first go over everything we talked about before. So first we could talk about data fields. So for a static data field, you initiate it outside of the constructor. So if you have something called dog count, if you put it outside of like the constructor over here, then it'll be defined as a static variable. Next, any instance variables will be created within the init function. So basically, an instance variable you'll have to refer to as self.variable name. So for example, if I pass in name from my constructor, then I can store it as an instance variable over here, self.name equals name. You can also set like default values for your instance variable. So like self.noise equals bark. Or if you don't want to set any specific value, like starting value for your instance, be sure to specify it as none. So you can't just like declare something like a static variable and leave it like this, or else it'll throw an error and Python will be mad. But so if you want to have something that doesn't have like a specific value to begin with, just make sure you store it as none first. So if we define this init function and we pass in like how many ever parameters we want into our constructor, then we can define instances of these classes and then pass in whatever information we need. So if I have like a parameter, like a constructor that takes in the parameter name AB, then I would have, for like, if I ever want to create an instance of it over here, then I still have to pass in like the matching number parameters. So name AB is the parameters I defined in this constructor. Then I'll have to make sure I pass in like the same number of variables into that constructor. Any questions about this? All right. Notice that for my constructor, I have to pass in self as the first parameter. It's because this constructor is technically like an instance method. You're just like creating and it'll actually do the creating of the instances. If I don't like have this constructor, then I won't be able to like create instances over here, and it'll throw an error because there isn't a defined init method. So if I do something like this, what you can also do is I can also show you how to like, just a sec. You can also access static variables within the class. So to access something like a static variable like dog count, just make sure you have to access it instead of doing like self.dog count, like you would do with your instance variables. You have to access it through the class. So that would be like dog.dog count. And then I can like edit it like this, or alter the value of the static variable. And then finally down here, I can do something like print dog.dog count. And this should print 2. Oh, this is throwing an error because I added these 2. So as you can see here, like I initiated 2 dogs, and each time I call init, it would increment dog count. So at the end, it prints 2. So this is just how you access instance variables and static variables, and how you can like define instance and static variables using init and like placing your static variables outside over here. Any questions about this code or anything like we talked about before? All right. So next we can talk about getters and setters. These are just generic names for methods that will get or set your variables. So getters will return like the value of whatever variable you pass in. Set will just set the value of that variable. The important part about this is it will let you access and change non-public fields. And in general, like there are 3 ways to implement it. First is like implementing a getter and setter as like a normal instance method. Next is just like using a at property tag, and finally is using a property method, which we won't be going over because it's very complicated and not recommended. So first, we can talk about implementing getters and setters like a regular method. So this is generally like going over how you can create a regular instance method and like how you can implement one way you could implement a getter and setter. Personally, I would say like this is the best way to implement it because it doesn't like it's simple, it's straightforward, and it's a lot more intuitive than the other 2 methods. And the most important, like the downside of it is that it must be explicitly called. So you can't just like you'll be able to see like for the other 2 methods that you can sort of make it easy, like make getting and setting pretty easy. But for this one, just remember, like if you implement a getter or a setter as a regular method, just make sure that like just remember that you have to explicitly call it in order to like change the variables of your or change the values of your variables. So we can take a look at the code and I would just walk you through like first, how do you define non-public methods or non-public variables? And then second, a very basic way of creating a getter or a setter. So first off, like this is just building off of the dog class that I talked about in the previous demo. So you still have like your dog count, which is the static data field that we defined last demo. But I've changed the visibility of both name and noise a little. So for you notice that I have 2 underscores in front of name and noise. And in Python, this is how you would define a private method. So remember, a private method is something that only that class can access, like only that instance of that class can access. So usually like for a dog, only they know their own name, and you shouldn't be able to access like the noise unless like they like bark or something. So that was like the logic I put behind that. But I made these 2 private methods or private properties, so private variables, so that nobody outside of that instance can access it. So they can't see it and they can't change it. So then if that's the case, like how would I, like what if I do want to change it in a certain case? How would I be able to do that? So for that, I would define a set, like setters that are basically instance methods in my class. So one is set name, which will just set the name to like the new name you pass in. Next is set noise, which will just set the self dot double underscore noise to the new noise you pass in. So this is pretty straightforward. You just set the private variable to this new value. Same with get. So what if I want to know the value of these private variables? Well, you could just return self.double_name, return self.double_noise. These are basically like, in this case, like these are just average instance methods. So you notice that I pass in self as my first parameter for all of these. And then in the main method, you just have to remember to, if you want to like get the name or like get the noise, or you want to set it, then you have to explicitly call it, like dog.getName, dog.getNoise, or dog.setNoise to Fred or something like that. So this is pretty straightforward. The only downside is like every time I want to like access a dog's name, I have to like call this method, and maybe it'll take like a few extra lines of code in your program. Any questions about this code so far? All right. So the next way we can define a getter or a setter is a little more complicated. So in Python, like you can tag your methods with like special tags. And one of them is the @property tag. So if you like, it allows you to treat like a non-public field like a public field. So and this is basically the general template for defining a getter and a setter that way. So you would define the getter as, you would first tag it like with the property tag. Then you do like def whatever attribute name, pass in self, and then return the self.attribute. Next, like for setters, we just do @attribute.setter, define the define a method with the attribute name, pass in self, comma value, and then do self.attribute equals value. And then after you like define it this way, you would be able to like just treat your private values like their public values. So you can just do like outside of your class, you can do like instance.attribute equals new value. And that would, like, even if that attribute is private, it would still be able to set it. So this would just like in general make your life a little easier. And I did do a demo of this, and I'm not sure why it did not show on here, but I can show you I'll share this link to you. Not this. There you go. All right, so here is just like a quick demo of how you can define a getter and setter using this fancy property way. So this is the same class as we had for the last demo. So you have like your static variable dog count, name and sound. You have an instance method called bark, which is just printing out the sound private instance variable. But if you notice, for like say I want to define a getter and a setter for my name attribute, and I want to use this fancy property way. So first off, we could look at the getter. So for the getter, you first tag the method with a property tag, so @property, and then I would define a instance method with that attribute name. So if I want to define a getter for name, then I would just do at property def name, and then remember to pass in self. And then for the getter, I would just return self.name. And then next we can talk about the setter. And you would tag it with at name.setter. So at attribute name.setter. And then it would be similar to the getter function, except I would also pass in like a parameter that would be the new value of this of my attribute. And I just set self.name to my new value. So what's the benefits of, what are like the benefits of doing this this roundabout way, basically? One of them is I don't have to explicitly call my getters and setters anymore. What I can do is just access my these attributes as public variables, basically. So if I create an instance of a dog called Fred, then I can just access my dog name as if it was a public variable. And then same for setting the variable. So if I want to change the dog's name, then I could just do dog.name equals Bob and then print out dog.name like that. So one of the benefits for doing it this way is just that you can save a couple of lines of code and you wouldn't have to worry about like, oh, do I have to call my getter explicitly and stuff like that. Any questions about this? Sweet. So finally, you can also use implement getters and setters using the property method. So basically you can define a static field that contains a property object related to that non-public field. So I can define if I want to do it, create a getter and a setter for my dog.name, then I can define a static field called name that contains a property object related to my name field. And then that would it's similar to the second method with the property tag, where it'll then allow me to treat the non-public field like a public field. And I can just post, we can just post the link in chat. And I personally would highly not recommend you do this because this one is way more complicated than the property tag method. And I personally don't see the benefits of doing it this way. But if you're interested, you should totally check it out. And we posted a link to a tutorial in chat. So far, any questions about classes or everything we talked about so far? I know it's a lot of information to take in. So feel free to if you have any questions at all, feel free to just drop it in chat. All right. Let me see if I actually have more demos about visibility, because these are actually pretty important. Yeah, so I can share more demos about the stuff we talked about in the first few slides, because it can get a little confusing, especially with Python's naming conventions. So first off, this is just a basic demo about class, the visibility of data fields. So just what are the differences between a public variable, a private variable, and a protected variable. So first off, like this is again the a class called dog, and we can define like three different instance variables. So one is color, another is name, and another is ears. So first, for public variables, you can just do like self.color. So no underscores before anything public. If you want to make a private variable, just like the last few demos, make sure you put a double underscore before it. And that way, nobody outside of your specific class can access it. So this could be useful if I want to make a solution. This could actually, because like, so if you want to make something like a simulation, sometimes like you would want to simulate like objects floating in space, right? Like objects within the solar system. So you can have like a class called Earth and an instantiate object called Earth. Or you can even have like a general class called like planet, and then instantiate different instances of planets called like Earth, Venus, or Mars, or something like that. And then you can sort of simulate a solar system like that. But the thing about like why you want to make certain things private and certain things public and other things protected is that sometimes like you don't want other people accidentally messing up your variable values, and you don't want people accidentally accessing things that they don't want to see. So basically, like, because in general, when it comes to coding, especially like when you're working on really large projects, is you aren't making like one simple app, or you aren't making like one small project that comes together really nicely. Sometimes you're making like entire libraries, and you don't know who's going to use that library, and you don't know like what they're going to do with that library. So sometimes you don't want people to see things and then accidentally change them, because maybe like this value will be important in a like another section of the code, and you don't want anybody but yourself touching it. And that's when you want to make things like private or protected. So in general, like this is pretty important when you're like worrying about privacy and like or visibility in your classes is pretty important if you want to like in order to make sure that like your values, the values of your variables stay consistent, and like controlling who can access it and who can change those values. So continuing on, like we can have like we can also have something called protected, and that's just we would just define that using one underscore. So protected we haven't really talked about because I'm not going to go too deep into like inheritance or like making subclasses or like any of that for now, because that it gets pretty complicated and there are a lot of like nuances when you talk about that. But in general, remember that protected, it means that that variable is visible and accessible only by your like current class and any subclasses of that class. So for example, this one, we have a protected instance variable called ears, and we defined it as pointy. So, but like for protected, we can also like have, what if we have like a subclass of dog called husky? Then like you can access your protected variables even in your subclass. So that's why like this is here. And this way, when we run it, as you can see, like it prints out, like you can print out dog.color just like regularly. Then you can like do dog.bark. You can print the ears, which are pointy, and then you can do like get name. So notice that like when I printed the ears, I didn't actually I didn't just print it like dog.color. I actually had to make my own method called print ears within my dog class in order to print them properly. So that's because like I can't access a protected variable outside of that class in my main method. And same with get name. So like this is an example of a getter. So finally, like let's look at why this. We'll like next look at the Husky subclass, and then we'll talk about why this isn't good. So we've created an instance of Husky. We've done like husky.bark, and then we printed the ears. As you can see, like they're pointing. And then finally, like let's look at what's up with get name. So for this one, let's see. The error is there's no attribute husky.name. So if we look at the Husky class, so ignore this part. This is just initiating like all the, or doing like all the inheritance stuff. So initiating all of these variables up here. But if we look at get name, this will throw an error because you can't access a private variable outside of that class, even if like I'm in a subclass. So unlike a protected variable, private variables can't be accessed by subclasses. So I'd have to like either initiate like let's say self.name equals hi or something like that. And this should be able to run. So any questions about the code in here? So I would highly recommend you look through this code and read the comments about like why about like the different levels of visibility and how you could like define like a private or a protected variable. And you can also like play around with this. Just remember, like if you want to change any code, just to fork this REPL before you do anything to it. All right, any questions? Otherwise, we can, let's see. Otherwise, I can try to find other demos I've made about this. But I think that is it. Oh, this one's a static method demo. So this one is just talking about like how you can, so we talked about like instance versus static. This one's just talking about like how you can create a static method. So if we go back to this slide, you can see static methods are methods that are tied to a class. Instance ones are methods that are tied to instances. So far in all of our demos, we've been dealing with only instance methods. So like we're passing in self as the first parameter, and we're calling all these methods using like instance.method. So like dog.getName or dog.setNoise, just things like that. So this is just an example of a static method. And I'll post this link in chat. So this is like the dog class. And then we have a static variable called dog count. So what if I wanted a static method that would return the dog count? So what I would do is I would first tag it as static method. So this is just telling Python like, hey, this is a static method, unlike these other instance methods. And then as you can see, we don't have to pass in self for that because the method is tied to the class and not the instance. And then again, just a reminder, if you want to access a static variable, you have to do it through the class name and not through like self.name or like self.noise or something like that. And then like a static variable, you access a static method through the class name. So if I want to get dog count, I would do dog.getDogCount instead of doing like dog or like dog.getName or something like that. and this would return 2. And then over here, it's like, yeah, if you want to access an instance variable, you would just do it through instancing that method. Any questions about that? Sweet. All right. Finally, we can just look through. I'll actually post these examples of methods, and we can also look through them and just check them out. So this is just an example of a different class. So in this one, you have like, you want to create a class called car. And first off, like you have your constructor. And in your constructor, you're defining like a list of instance variables. So you can store anything you pass in to the constructor using like an instance variable. So like self.brand equals brand, self.color equals color. You can also, again, if you don't want to like store any initial value in particular, just remember to assign it as none. You can also like store things like lists and dictionaries. And then we can define instance method, so like description. And then this will just like return a formatted string of like what the color and brand of the car is. Finally, you can like, these are just like getters and setters for the manufacturer year. And you can like look through these yourself. And then afterwards, like this is just a demonstration of like, you can create an instance of a car. Just make sure you pass in like the proper amount of parameters that you defined in your constructor. And then because we use the property tags to define the getters and setters in this case, we can just treat like a non-public variable as a public one. So I can just set the manufacturer year using the equal sign instead of using like a specific method to do it. And then finally, you can like just call your instance method using instance name dot instance method. All right. And it looks like we have time. So I can just go over like just a really quick overview of the 4 principles of object-oriented programming. So these are like the 4 principles of object-oriented programming are just things you should take into consideration when using a language that supports object-oriented programming in order to be able to take full advantage of an OOP language. So this is what you should be thinking about when like you're creating classes in Python or like any language in general that supports like making classes and instantiating things. In general, like these are basic design principles. So just how you should be designing classes and things to keep into consideration. The reason why like people use these principles or they program by these principles is it helps prevent a lot of unexpected behavior. So this like helps you keep your code clean and keep your code sort of organized in a way that like you don't get weird bugs that come out of nowhere. So I'm going to focus mostly on the first 2, which are abstraction and encapsulation, because these are the ones that we talk the most of, or these are ones that use the, I would say like the concepts that we talk most about. So like things like protection, things like data visibility and just like visibility of methods and variables. So first principle is abstraction. And this is in general, like this is just saying classes don't have to know what's happening under the hood in order to interact with each other. So for example, if I call like dog.bark or something, I don't have to know what's happening, like what's happening in that function in the bark function in order to be able to call it. I can just call it and then know like, oh, it'll return like a string or it'll print a string. So what's like the advantage of this is that it allows us to plug in different implementations of classes without drastically changing our code. So for example, like if you have a giant piece of software, like something like something sort of like Photoshop or something, and you change like one class within your program, and you like change it, you plug another class in, and or like you plug a similar like version of that class in, but like what's happening under the hood for that class has changed a little bit. If I make small minor changes to that class, it won't suddenly change the rest of the code, and I won't have to like go through like 1,000 lines of my program in order to like compensate for one small change in like one tiny portion of my code. So this just allows our code to be a little more modular, and it allows it to be it makes each class independent of each other basically. The second one, and this is the one I kind of talked about, is encapsulation. So class attributes should be kept as private as possible. So the general gist is if other people don't have to see it, then I should make it completely private. And variables should only be on, it's sort of like a need to know basis, where if other people don't have to see it, then they shouldn't see it. And this just prevents other classes and other people from modifying data accidentally. And that in turn prevents like a lot of unexpected bugs from happening. So in general, like this is super important, especially if you're creating sort of like libraries or APIs for other people to use. And yeah, just keep this in mind. So the third and fourth one are polymorphism and inheritance. So polymorphism is just we can perform one task in many different ways by creating subclasses. So like if I have an overall class called dog, and I have like a bunch of different subclasses of like husky, wolf, beagle, or something like that. So different types of dogs. Then I can perform, and each of these classes has like a bark method or something, and they emit different sounds. Then it's basically like I can perform this one bark method on my many different subclasses, and they'll all have different outcomes. Finally is inheritance. Like when we make a subclass, it also inherits the attributes of its parent class. So as you could, like, if we go back to let's see if I still have it. So if we go back to the class visibility demo. So over here, we had like a general dog class that had like color, name, ears. And then we had like a husky subclass, which had which didn't add any extra instance variable. But I could, like, even though it didn't add anything extra, I could still access like the variables of my parent class, which was dog, that shows like how basically all the instance variables over here generally get passed on into my subclass unless specified otherwise. So for example, like I said name was private, so that doesn't get passed on, but both color and ears do get passed on to husky over here. So in general, like a parent class will pass down its attributes to any subclass that has.